So this is a problem from test in 2015. It's problem number 3, so no calculator. And it is a table problem because the first thing we're seeing here is a table at the top. All right, so it starts with Joanna jogs along a straight path, which almost kind of feels like a particle problem also, right? From time 0 to 40. Joanna's velocity is given by the differentiable function v. So since this is actually a rate, what that's telling me is this is her speed, or her velocity rather, throughout the jog. It also tells me that they're probably going to ask me to integrate to find her position, and then also take a derivative maybe to find an acceleration or something like that. Okay. Selected values of v of t, where t is measured in minutes. Okay, that's already labeled there. And v of t is measured in meters per minute, right? That is the velocity, are given in the table above. Use the data in the table to estimate the value of v prime of 16. And it says estimate, right? Because 16 isn't given in that spot. Really, all they're asking us to do is just find the rate of change. So the change of y over the change of x, right? So the change of y is 40, right there. Right there is 40. And the change of x is 8, which is going to be 5. And we're going to say meters per minute, or per minute squared. I'm going to box that guy up. Easy peasy, lemon squeezy. All right, next one. Using correct units, explain the meaning of the definite integral, and it has an absolute value around this. And as soon as I see the absolute value, it's telling me her speed, or her velocity, right? Her velocity, absolute value, it's going to be total distance that she's gone. In the context of the problem, approximate the value of this guy, right? So integrating it from 0 to 40 using a right Riemann sum. Right? So like I've said before, you might be able to, starting on the right side, just be able to start figuring out the bottom, the base of the rectangle and the height, and then the base of the rectangle and the height, and the base of the rectangle and the height. But once again, I'm just going to plot some points real quick. All right, so over here, going, looks like I need 0, I need 12, I need 20, 24, and 40 is going to be a little bit further down, right? And then this point is going all the way up to 150. 150. And this one is down to negative 220, but it said the absolute value, so it's actually going to be up to 220. And this one is 240. And then the last one is 200. I don't really have to worry about the other one, which is 0, 0, just because when I draw these rectangles in here, it's not going to make a difference. I'm drawing a right Riemann sum, so from the right side going up and over, making my rectangles. Up and over, up and over, up and over. And so really I just have to find the area of those 4 rectangles. And the hardest part about it is, or the most tedious part about it is no calculator. So here on the bottom we have 12 times, I'm going to write them down, 12 times 200. That's going to equal something. And then this is a distance of 8 times 240 is the height. Next guy is 4 times 220. And last one is going to be 16 times 150. And you might have to do some of these off to the side or something. What can we do to be clever to figure out what some of these are without having to multiply things? 2 times 12 is going to be 24 with 2 zeros, right? Which other one can I do pretty quickly? Well, 15 times 15 is 225, but then I have an extra 15. So 225 with an extra 15. 225 with an extra 15 is going to be 240. 240 with an extra 0. Right? Double this twice. So 22, double it and you get 44, and double it again, you get 88. 88 with a 0. And this one, I guess I'm going to do that again. I'm going to double it, and double it, right? Because that 2 times 2 times 2 will be 8. So 24 times 2 is going to be 48. 48 times 2 is going to be 96. And 96 doubled is going to be 292. 292 with an extra 0. Add all those guys up, right? And like I said, this is the most annoying part of the AP test, is some things like this, which should be quick, end up being much more tedious. That's a 0, carry the 1, so that makes 10. That's going to make a 6, and carry it, that's going to make... And there's our answer. Okay, and I'm just adding those values up. So the one thing I would be careful of is making sure you answer all the questions here. And the question was, how far did she actually run, right? Because that's what the thing is representing, and I'll explain that in just a moment. So it's going to be 7,600 meters is how far she went. And what does that thing represent? From 0 to 40, v of t dt represents how far she jogged in meters. And you have to mention the units, right? So how far, that represents how far she jogged in meters from, not for 40 seconds, but from, and it's in minutes, right? Minutes. From minute 0 to minute 40. Okay? And I'm going to go ahead and section that off a little bit. So we have the answer to the question, and then we also have what it represented. All right, next part. And they do this a lot, obviously. You've seen it quite a few times where they have a problem that represents Joanna jogging, and then suddenly they introduce Bob, who has nothing to do with the problem. Okay? But Bob is riding a bicycle along the path from 0 to 10. So this is a different interval, just from 0 to 10. And Bob's velocity is modeled by, and this is a little surprising to me, most times when they have a problem like this, they wouldn't give you velocity again, they would give you position or something different to switch the problem up a little bit. But this is velocity again, where t is measured in minutes and b of t is measured in meters per minute. So same thing. Find Bob's acceleration at t equals 5. So that's actually pretty straightforward. This is velocity, so I'm going to go, the derivative of b is b prime, and the derivative of this thing is going to be 3t squared minus 12t, and then the 300 is gone, right? Just using the power rule. So from here, I have to plug in a 5. So we have 3 times, that's going to be a quarter, that's going to be 75. And plugging in a 5 in here, 12 times 5 is going to be 60. So final answer is going to be 15, and I'm going to use the units. 15 meters per minute squared. Meters per minute per minute. Okay. And last part. Based on the model B from part C. So based on this model, based on that model from part C is right there, find Bob's average velocity during the interval from 0 to 10. Okay, so average velocity. This time I'm not just going to plug in the endpoints like it said before. It said average, find the slope basically, right there, the average slope. This is a little bit different. This is an average where we have to add up all the velocities and then divide over the interval, which is 10. Okay, so adding up, I'm going to integrate, and I'm going to integrate t cubed minus 6t squared plus 300, and I'm going from 0 to 10, 0 to 10. And then I also, this is adding up all the velocities over that interval. Now I want to break it back down over the interval. So I want to divide it by 10. Okay. If it was calculator, this would be worth a point, and it is, and then just the answer would be worth a point, but here I have to actually go through the process. So integrate this, is going to be t to the 4th over 4 minus, and this is going to be t to the 3rd, divide by 3, the 6 is going to be divided by 3, so it's just going to be a 2, plus 300t. Right, and I still have to plug in 0 to 10, and I still have to not forget about that divide by 10. Don't let me forget about the divide by 10. So plug in 10. 10 with 4 zeros, right? Because it's to the 4th power. 1, 2, 3, 4. Divide by 4. And then this one is going to be t to the 3rd, so 10 to the 3rd. So it's going to be minus 10 to the 1, 2, 3, but it's times 2. So I'm going to double it. And then this one is times 10, so it's going to be plus, and that's a 3,000. So that's the 10 being plugged in. Now I need to take away the 0 being plugged in. And so 0 plugged in is 0, and then 0 plugged in is 0, and 0 plugged in is 0. So I don't have to worry about that part, luckily. All right, let's try to figure out some fancy math here. That right there is going to be 25 with 2 zeros. So 25 with 2 zeros minus 2,000 plus 3,000. Don't forget to divide by 10 at the end. Okay, so that right there is 500 plus 3,000. So 500 plus 3,000 is going to equal, I'm going to just stick it right over here, is going to equal 3,500, but I'm dividing by 10, so it's just going to be 350. It just knocks off one of those zeros. And I will mention the units. It's going to be meters per minute. Right? This is the average velocity, so that is velocity, meters per minute. Box it up. All right, so hopefully you're pausing along the way. Hopefully you're challenging yourself a little bit, and hopefully you're just having a little bit of fun, right? Maybe even go for a jog after this.